Welcome to today's webinar brought to you by Influx Data, Delphix, and Datavail. I'm Stephen Fegg, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Achieving Performance, Flexibility, and Security in the Cloud. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question is not selected during the show, you will receive an email response. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we have Bharat Bhatt, Director of Product Marketing at Influx Data, Corey Brune, Enterprise Technology Engineer at Delphix, and Michael Agarwal, Director and Global Practice Leader for Cloud Databases at Datavail. Now I'm going to pass the event over to Bharat to get us started. Welcome to the broadcast, Bharat.
Hey, Stephen. Thanks for the intro. We'll get started. I'm Bharat Bhatt. I'm the Director of Product Marketing at Influx Data. Thanks for joining our session today. I'm going to talk about a new way of thinking about database management and application development that harnesses intelligence from data by relating it to time. We'll also go over how this affects various monitoring systems and plays heavily in the increasingly ubiquitous space of consumer and industrial IoT. I'll finally touch on a new feature that we launched this week called Edge Data Replication. Really excited about it, which allows you to get the precision of the edge with the power of the cloud. It also provides a layer of security at the edge. If you want a deeper dive into the technical architecture of some of the concepts I'll be covering, please make sure to check out our resources section at the end of the presentation. So let's begin. You guys know this, there's many tools out there for developers today. So some of them are pretty straightforward and have clear pragmatic value. Let's say like an IDE like PyCharm or IntelliJ or VS Code or Terraform scripts for deploying your code and Postman for testing your APIs. I could go on, but as most of you know, there are a lot of amazing tools out there for developers that are easy to grok and relatively easy to set up and deploy. One of these tools that many developers have not heard of is a time series platform, which at its core has a time series database. And with these tools, you and your team can fundamentally change how you improve your engineering systems, processes, and the underlying business value of your product. Time series platforms are powerful developer tools that you can use to manage data that is deeply tied to your business outcomes, that fundamentally and philosophically changes the way you think about designing your product, defining your product value, and most importantly, delighting your customers for years to come. Time series focuses on the idea that the most important decisions that you have to make in engineering and business are based on how your data relates to time, which translates to having tools and database management systems that developers can use to handle data specifically in the context of time. We're all trying to build smarter systems and systems that are automated, detect anomalies, and eventually predictive intelligence, and eventually are self-healing systems. And all smarter systems start with better instrumentation and better telemetry. And most of the critical decision-making data in your systems are understood in the context of time. To manage that data, you have to first understand how it fits into your specific use cases and the way that you collect, query, transform, and act on that data. We at Influx Data have a purpose-built time series data platform that helps you build IoT, real-time analytics, and cloud applications at scale. This tool is especially important when you think about handling the massive amounts of data that come in from sensors, analytics, or SaaS applications. Time series, again, it's a relatively newer form of database management system. Allows you to find, and one of the core things that allows you to find insight and correlation in your data within the context of time. And that's far more cumbersome and in some cases not possible to do with relational or document DBs. Some of the problems you may find by using RDBMS or document DBs are changing schemas on the fly, indexing and storage issues such as poor compression and no native downsampling, which is kind of the eviction of data. And you need to do that when you have, especially when you're doing large scale like IoT stuff or a lot of sensors. So what is time series? So time-based data can be in days, hours, minutes, and even nanoseconds. And not all time series databases support nanoseconds, but InfluxDB does. And these sometimes occur in regular intervals, and sometimes they occur in irregular intervals, which we like to call events. And time series platforms can handle both irregular data, and irregular time data, and a combination of the two. And these can actually come from many sources, which takes me to the next slide, where if you think about it, there are both physical sources like sensors, devices, edge gateways, networks, and systems, and virtual sources, including DevOps, infrastructure, and of course, cloud applications. We are seeing a massive growth in recent years for connected devices, IoT, and sensors. SaaS applications, of course, too. And also, these often need real-time analytics and actions to be taken. Time series database management systems are uniquely positioned to handle this type of complexity, growth, and real-time analytics. I've already talked about this a little bit before, but as you can see, like RDBMSs, document and so relational databases, document and search DBs are great at certain scenarios. And we know that, especially when you have a lot of binding relationships between tables and in the schema, but they struggle both with scale, storage, and performance with timestamp metrics, events, and timestamp data for example, IoT, real-time analytics, and cloud applications. In building InfluxDB, we thought about it and we think about it in two ways. First, we want to enable developers to build and integrate applications with time as the foundational component. And this is about developer experience. Our goal is for developers to get up and running really quickly. And second, once they're up and running, we want to enable those same developers to scale massive data workloads in those applications and do so at high volume and distributed globally. And this is about performance and scale. What's important is that the same time series platform satisfies both of those requirements. The newly arrived users are building on the exact same product that the largest global customers are using at scale. And this is kind of just a slide to show you guys like the foundational components. What is InfluxDB? So we have an API toolset, we have an engine, and then we have a really large community of contributing developers. So a really strong, big, massive fan base and contributors on GitHub. So I mentioned this earlier. One of the really cool time series capability is how we can help developers fuse the devices at the edge with other edge devices and in the cloud. So with edge data replication, you get the precision of the edge with the power of the cloud. You can replicate data from all your edge devices and sensors to cloud seamlessly. It's a durable queue-back service that lets users replicate their data between InfluxDB at the edge and another InfluxDB instance, such as whether it's on the cloud or on the edge. You can also sync data between InfluxDB edge devices in a secure manner and take action in real time. And we just launched this this week, so really excited about it. And I think it's a capability that you can't find it really anywhere else. But when you look at this, basically we're saying that there's just a lot of data at the edge, and that number is growing exponentially. Developers need to ensure that the edge and cloud data layers work together in a simple and efficient way to deliver centralized business insights in near real time. What does that mean? I mean, that means that you want to be able to see all these insights in one place. So if you have all these devices at the edge, they need to send that to the cloud, and that way you can actually have a centralized kind of insight and monitoring. Up until now, architecting an edge to cloud integration required significant upfront and ongoing developer investment, right? Making it expensive, time-consuming, and error-prone. If you think about it, even just at the edge layer, developers have to allow API access, manage the edge data layer, integrate with automation and controls, manage locally served dashboards. I can go on, write delivery code, for example, for alerting systems, right? If you combine the top cloud tasks on top of that, it's easy to see how edge to cloud integration becomes a challenge for developers to effectively manage and use. So So we've made that we've given developers and organizations kind of an easy button to do that. And then regarding security, I mentioned this earlier, you can allow devices to be intentionally sealed off and live in an air-gapped environment when it's necessary. Think about it kind of like as a sandboxing the edge gateway. So edge data replication makes it possible to safely replicate data from InfluxDB, we call buckets that are at the edge, to InfluxDB cloud buckets in real time, meaning users can now collect, store, analyze high-precision time series data from the edge and view that data in the cloud. And we just want to say that you get a lot with you get ingestion integrations to do that. You can you use any of our 13 plus popular languages and frameworks, and we have over 300 integrations actually for ingesting data. So you get all of that with just InfluxDB and InfluxDB Cloud. So what's next? So the utility of time series database management systems is really vast. There are developers that are using time series tools to monitor the delivery of payloads into space. They collect, and I mean, it's pretty amazing. They collect and store IoT's data, sensor data from their equipment and satellites, greatly increasing their mission success by ensuring resiliency in critical launch and operational components. Back here on Earth, renewable energy is another application where sensors instrument energy usage on electrical grids, and the excess energy is sent over to power solar panels, for example. Urban and vertical farming use time series data to ingest and store metrics such as temperature, light, air, moisture from farm sensors to keep their products fresh, and these metrics alert them when thresholds are breached. So these are really applications that really help people across the world. And we're witnessing the instrumentation of every available surface in the material world: streets, cars, factories, farming, power grids, clothing, human bodies, and even spacecraft, as I mentioned. And these devices generate more data than we've ever experienced. All of that really is in the language of time series. So all the sensor data is actually its lingua franca is time series. So there are many, so if you're using time series to harness the insights that data provides in the context of time. So, as a developer using these tools, you can create engineering business systems that are more intelligent, handle new workloads with resilience, scalability, and extensibility. And one day, maybe, you can create systems that are so smart that they're fully automated and even self-healing. So that's it for me. Please check out our resources. We have technical papers and links to help you get started. You can always go to www.influxdata.com/cloud to learn more and get a free account. I really hope this session has been useful to you guys and helps you embark upon or dive deeper into your journey through time and data. Thank you. Back to you, Stephen.
Thank you very much, Bharat. At this point in time, I'd like to introduce our second speaker today. We have Corey Brune, Enterprise Technology Engineer at Delphix. Welcome to the broadcast, Corey.
Thank you, Stephen. Yeah, my name is Corey Brune. I'm a Principal Engineer at Delphix. I've been here for almost 6 years now. And today what we'll go through is talking about how we can accelerate and secure data in cloud architectures. So just a few years ago, many companies actually were still in traditional data centers. So they were not really even having plans to move to the cloud. Now, fast forward a few years to the present day, and we're really looking at the vast majority, if not all companies now are really into the cloud, be it either fully enabled into the cloud where they don't have any data center, or they have only data center into production data centers, and then everything else is in the cloud. So it's a mismatch between that now, and really more people are moving even production data into the cloud. Okay, going to the next slide. Next slide, please. So this really presents challenges from a DevOps perspective. Oh, go back one. In that, in DevOps world, what we really want to do is be able to speed as much as possible, right? So if we have CI/CD pipelines, we want to go fast. We want to be able to test efficiently and be able to move everything up to production. Well, with the growth of data inside of enterprises, 5-10 years ago, we're looking at databases that were typically right around, a few hundred gig. A few years later, they're mostly in terabytes. And now we're seeing that databases are typically in terabyte ranges, and they scale up now even up into the petabyte ranges, which really, when we're talking about migration to the cloud, that really slows down and adds a ton of complexity to that migration. So if we're moving, say, production workloads from on-prem to cloud, or even from one cloud to a different cloud provider, how do we take that much downtime in order to copy that data over? And then once we do have that data inside of our cloud, how do we get a multitude of environments for dev, test, QA for all of our different environments? Typically inside of the cloud, we're talking about pretty expensive storage when it comes to databases. We're talking NVMe, SSD type devices in order to gain the performance that we need to in the cloud. And that's very cost prohibitive, especially if we have data sets that are in the petabyte ranges. So there's two different options that we typically see. One is time slicing. So we'll have one group in the database for 2 hours, and we'll have the next group in there for another couple hours. Or the other aspect is subsetting. So we can subset the data and be able to have more teams working, but that's problematic as well when we're talking about production applications, in that if I'm subsetting my data, I typically am not getting a full, rich context of data for my testing, and that typically will lead to higher amounts of data-related defects in production. So what Delphix is doing now is we have a cloud engine inside of any of these clouds. So what we're doing is we're leveraging object storage. So, for instance, S3 and AWS, we're actually leveraging that for databases. So one of our features is that we're making that more performant, in that if you spin up and use a database that's, local and into S3, we can make that non-production database very fast. So developers and testers can test against that, and companies can save the enormous expense of SSDs or NVMe type disks. And that will also allow us to be able to use a lot more data with a small amount of cost. So one of the transactions or one of the actions inside of cloud is we always want to be as fast as possible, meaning that we want to be able to automate pretty much every action that we have. So within Delphix, what we have is Data Control Tower. And this is a piece of software that can manage all your Delphix instances and tell Delphix, hey, I want to spin up 10 different virtual databases in the East region for my DevOps group, 3 virtual databases in the SRE group in the West, and for advanced analytics, I have a group out in Europe. I need 20 spun up there. We can do that and leverage one piece of software, leveraging APIs. So again, we can put this into a CI pipeline or some type of workflow if we want to, and be able to spin up these instances dynamically. And now, obviously, as we spin them up, as the groups finish testing or finish development, we can spin those instances back down so we're not charged as much. The other great benefit to Data Control Tower is I can use Terraform, so I can integrate everything in with Terraform, but also I can do reporting. So I can report who's doing what when. So if I have a security audit or anything to that effect, I can hand over reports to my auditor. I can also be able to do policy-based restrictions all through Data Control Tower. Okay, one of the main reasons for using Delphix in the cloud is really helping accelerate that migration. So like what we were talking about before, where we have terabytes or petabytes of data, either on-prem or from one cloud to another cloud, we have petabytes of data, or even terabytes of data. How do we move that over without taking a large amount of downtime? With Delphix, we have replication, and with replication, we can not only encrypt the replication streams, but also compress the replication streams. So what we can do is, the very first time, we'll do a full copy of whatever data set that we have, database, flat files, whatever it is, and then have that replicated over to our cloud instance. Once it's there, we can set up a job, schedule a job for however often we want to do syncs. So if we want to do syncs, every hour, every day, every week, whatever that cadence is, that's configurable by us, again, through API calls. And we can replicate that over so we can make that seamless. So we can set up a replication job, say a month in advance before cutover, and then as soon as cutover happens, we can say, okay, stop that replication job, spin up all my virtual databases. Okay, trying to go to the next slide there. And then with Delphix, we can be operational in pretty much any cloud, OCI, AWS, GCP. And the great thing too is, using replication, we can replicate to any other cloud provider as we need to. So we can automate this. We can go use a UI if that's more of our comfort factor. But the important thing is, through Delphix, everything can be automated. So what we can do here is really, truly avoid vendor lock-in, so we can replicate our data anywhere else. And again, with replication, we're not doing full copies every single time. We're just copying the deltas over from one place to another place. So, and everything is also encrypted. All right, one other aspect in the cloud is that zero trust. So going from high trust, which is typically in data centers, to zero trust. So, where we want to authenticate and, authorize everyone that logs in. With Delphix, we have very fine-grained authorization tools. So we can tell a developer that they have access to whatever type of data sets that we want in there. We can also do that to QA, and then also with our administrators. We can tell them they only have access to a certain amount of resources. So it's very fine-grained within Delphix what we can do from a security standpoint. And everything is also audited. So any operation that happens within Delphix also gets logged. So if we're creating virtual databases, if we're refreshing any operation, everything gets logged. Even if we're using the API, any action gets logged to the audit log. All right, we have a security tool within Delphix. It's called our continuous compliance. And with this, what we can do is secure our data. So if we have PHI or PII type data, we can go in and automatically look at that data, determine what data sets we believe, Delphix believes, needs to be sanitized. We can also, as users of the product, we can say, these two columns we don't need to mask, but we do need to mask a number of other columns, and tell Delphix what we want to mask. So we can do that transparently through one database or n number of databases. So in our application, if we're supporting, say, 5 different databases and Bob Smith occurs in, say, 3 of those databases, that Bob Smith will become Corey Broom transparently through all those other databases. So Delphix will make sure that everything is referential integrity aware, and that all the values are synced up between the databases. So that means that when I do testing, when I'm in QA, that all my records or any test cases that I'm writing will be found. If there's any data-related defect, I'll understand exactly what those problems are. So when we move up to production, those data-related defects that we typically would see in prod, where the records aren't synced between databases, we'll see those minimized because of this type of application. Okay, and I'm going to my next slide here. Okay, so on this next slide, we are on continuous compliance. Okay, I want to go to this next one. So within our continuous compliance, again, we can go through and update all of our records as we see fit. We have algorithms that are inherent in the product, so we don't have to spend time writing new algorithms or anything to that effect. We can go through and use the algorithms that are in the product, or we can also write our own. So if we have any additional algorithms that are outside of the box, we can do that very easily with Delphix. So with our continuous ransomware product, this is extraordinarily great for organizations that have actually ever had to go through this. Also for those that fortunately have not. What we do is we'll ingest data from a database or from a flat files, whatever that data is. We'll ingest that data. But unlike our other products, virtualization, what we'll have is we'll ingest that and make that a read-only copy. So if we are attacked by ransomware, we can restore that with a high degree of confidence that that has not been attacked. So we can restore that into another virtual database and restore that up to production if needed. All right. Again, my name is Corey Broom. Thank you for everyone for your time. Back to you, Stephen.
Thank you very much, Corey. At this point in time, I'd like to introduce our final speaker for today. We have Michael Agarwal, Director and Global Practice Leader for Cloud Databases at Datavail. Welcome to the broadcast, Michael.
Thank you, Stephen. Hello, my name is Michael Agarwal. Before I cover how to achieve performance, flexibility, and security in the cloud, I want to kind of give you a little bit background about me. I have 24 years in information technology. I kind of grew around software development, DBA. I was a technical project manager before. And last 7-8 years, I have been spending a lot of time on cloud architecture, DevOps, CI/CD, Terraform, all those aspects of it. Currently, I am a global practice leader at Datavail. We help customers move to the cloud, optimize in the cloud, and kind of build a center of excellence in the cloud. I have worked with Hertz and AWS in past, and kind of enjoying right now at Datavail. A little bit about Datavail. We are roughly 1,000 plus consultants globally. We have locations in US, Canada, India, Colombia, and Sri Lanka. And we are also have the Oracle Platinum partner, AWS Advanced Consulting partner, and Microsoft Gold partner with Azure credentials. We have also invested in some IP we have developed for our consulting services, managed support, and we can talk more if somebody has questions. We can talk more about Datavail and their offerings in a separate discussion. So you have seen this diagram before, very likely. 6 R's: retire, retain, rehost, replatform, repurchase, refactor. But why I'm bringing this slide? I think we want to discuss today performance, flexibility, and security. So how these 6 options gonna impact the performance, flexibility, and security. As you go from a infrastructure as a service where you're just creating a VM in Azure or EC2 on AWS, as you go from more platform as a service where you start to go to, for example, AWS RDS or Azure managed instance for SQL Server, you start to see that some of the responsibilities are now taken by the cloud provider. That means now the security aspects of it is also taken care by cloud provider. And as you get to the SaaS platform where you actually consuming services just from a browser, just logging to a website, even a greater aspects of security is taken over by the service provider. Similarly, as you go from infrastructure as a service to platform as a service, you can see that now you start to have more flexibility in terms of achieving a higher performance and achieving a better throughput with multi-AZ. For example, you can do high availability. You can do disaster recovery a whole lot easier as you get to the platform as a service. In some cases, the HR, HA, and DR is kind of built into the service, and you don't have to do anything extra. So what are generally the technical drivers for moving to the cloud? And so I'm not going to cover today business drivers. Business drivers could be at the high level. It could be you want to build a new product, you're competing, time to market, you have a new product line. All those are really good reasons for all those are good business drivers. For technical drivers, you might be looking to reduce the cost. You might be want to find a way to or easy to auto scale. What that means is in some services in cloud, the auto scaling is built in, so you don't have to do anything. For example, DynamoDB, AWS DynamoDB is one of those services. In some cases, you have to just put a auto scaling yes or no, so it's easy to configure. If you compare that to on-prem, it's a lot easier to do in a cloud. It's easy to scale globally. So both AWS and Azure, they have multiple regions globally. So in this case, if you have a global customer base also, and you want to be close to the customer base, you have that option to deploy the same solution globally and able to have a low latency connection for your customers. A lot of times the on-prem hardware is either older or is hard to upgrade, or the whole cycle of purchasing, putting on a rack, network connection, all those could take a long time. Doing that on a cloud, you just spin up new resources and use it. So it's a whole lot faster. It is a whole lot easier to modernize application and databases in cloud. You have tools like CI/CD, which makes it easier. You can do CI/CD on-prem also, but there are a lot of more cloud-native tools which makes it easy. You have a lot more modern ways to host the APIs, more of a platform as a service. So instead of hosting your APIs on a virtual machine, now you have a more managed layer. And then there are many other features that makes it easy to modernize your application and databases. Some of the use cases we see for application modernization are customers are moving from monolithic to microservices. And on the database side, we see lot from a commercial databases like Oracle SQL Server to more open source like MySQL, PostgreSQL databases. And in some cases, the relational database is not good enough anymore because it's not scaling as it need to, and they're considering customers considering a NoSQL platform. I covered earlier how easy to configure HA and DR. For HA, sometimes it's as easy as just setting a flag. A disaster recovery, copying your data snapshots to a secondary region is just a simple configuration, and then you have a DR. The one thing about cloud is a lot of times the DR is built within a region. For example, AWS, for example, has 11.9 durability built in, and in for example S3, there are 6 copies of the data. So there's a disaster recovery, some kind of copies already there. But if you want outside the region, there's also very easy to configure. I covered earlier about licensing. Specifically around Oracle and SQL Server. Sometimes the licensing cost is the factor why the customer want to move to cloud and try to adopt open source databases. The DevOps is a lot easy to configure. For example, AWS code pipeline has both build and deploy. And Azure DevOps, for example, has same build and deploy, and then you can reuse any code repos, whether using GitLab or something native like code commit on AWS or Azure DevOps for your repository. The infrastructure as a code, for example, Terraform, we use Terraform for both AWS and Azure. CloudFormation on AWS and ARM template on Azure. We use that almost in all projects. And the benefit there is now I can take the same code base and I can deploy test, dev, production environments, and I have a copy of what I deployed using my code, and I can make changes if I need to. As you go to cloud, the things like data center security, who are coming in and out of data security, a lot of managed services, platform as a service, they provide a higher degree of security simply because most of the responsibilities in this case are taken care by the cloud provider, and there are certain smaller degree of security and responsibility that falls on the customer. So I covered some of these earlier, but I will cover some of the gaps. So performance, if you look at network within a region, you have single digit millisecond latency. So that's give you good performance. The disk, you have your traditional hard drive. You can do general purpose solid state drive or provisioned solid state drive. All those options are there, gives you performance and also flexibility to what you want to use in terms of disk performance. You can scale a instance, for example, anywhere from, and this is changing, is increasing. I now see 1 terabyte being proposed as a memory, for example. So you can go from half gig memory to 512 gig memory. You can go from 1 core to 128 core, and you can vertically scale your instances, and you can do that your maintenance window, and then in that case you have that flexibility. Some applications call for horizontal scaling. This is where I think the power of cloud comes in. If you're using VMs, so EC2 in AWS or VM in Azure, you can put them in an auto scaling group behind a load balancer. Of course, Dockers and Kubernetes, all those are also aspects of to kind of deploy in a microservices and kind of scale each and every microservices independently from each other. And that's where the orchestration from Kubernetes is very helpful. The serverless components a lot of times already have a built-in scaling. For example, AWS Lambda, I can have 1,000 invocations at a time. So it can scale to 1,000 invocations. NoSQL databases where you can have multiple nodes in a cluster, and they kind of all work together to satisfy the need of the application performance. Also load balancer kind of help distribute the traffic to multiple nodes. If you have a web server, for example, or if you have a worker node, for example, picking up from memory queue and processing some workload, you can distribute all that through load balancer, SQSQ, and many other technologies are there to give you horizontal scaling. And if you are in a high-end computing, the GPUs are there, and quantum computing, those are all new computing platforms which give you and you can rent by hour, minute, second, and pay for what you use. And then these are high-end computing resources. They cost a lot of money, and that's where you want to be careful what you use, and when you don't need it, destroy it so that you don't keep getting the bill. Cloud also give you flexibility. If you're doing infrastructure as a code, of course, you can spin up multiple environments with the same code. You have version control, and there are many other benefits of using infrastructure as a code. If you don't need a resource, you can destroy it, and then you only pay for what you use. That allow you to experiment a lot more often, and only keep the things you like, or only keep the things which are being accepted by your customer. It gives you very easy way to configure high availability. It gives you very easy way to configure disaster recovery. And the other flexibility is you get to the if you have a new project coming where you do need a lot of servers, compute power, you don't have to wait for order, in a long time back. You have to order the hardware and three-month procurement, purchase order, whatnot, and then putting on a rack. All that kind of goes away. That hardware is available by a cloud provider that you can use and spin up things you need and use those resources. As you move to the cloud, you have option to stay same, or you can modernize using cloud native option. And that's where I think the focus is these days, where we see customers actually modernizing their applications and databases and going more cloud native. On the cloud, you have option to use virtual machines, container serverless. There are many options to use compute. You don't have a long-term commitments. There's generally no licensing fees unless you get it from marketplace, and there's generally no upfront fees cost unless you go for like reserved instances where some discounts apply. So there are some rare conditions where you do have an upfront cost. It's also very easy to do security because cloud providers start to take more and more responsibilities. So as you go through the compliance audit, you will see that roughly half or more of the things are already check mark, already compliant, simply because those are provided by the cloud provider, and then the other half you work on to make sure you stay secure. It allows you to use keys. You can have your own keys, or have AWS or Azure kind of provide you those keys that you can use to encrypt or decrypt. You can manage certificates like TLS certificates and have the whole life cycle to renew and apply certificates. Secrets for your application and databases, you can manage them securely. It allows you to easily manage permissions, whether it's permissions for your developer or your applications, and all that through you define those permissions using the code, and so it's very manageable and very structured in a way that is allowed for a good security. You can also implement security as a code, and most of the companies I work with, they are going security as a code. They are implementing DevSecOps, for example, and many other things to start doing security as a code. It brings up more security and compliance in place when you use code for the security. It also have a way to quarantine, auto remediate. So if a problem happens, I can set up triggers and alerts and remediation actions, and I can invoke actions such as it can quarantine the resources or shut down. So there are a lot of automation that you can do. With that, I wanted to kind of point out, the performance, flexibility, security, all that is very important, but that kind of bring into the umbrella of center of excellence. This is where a framework is placed within an organization to follow a framework, whether it's a security, whether it's an application, databases, and kind of keep everybody on the same page. It provides the guidelines within the organization as well as any vendor who is joining and helping you in your cloud journey to kind of follow that same guidelines and bring that excellence in the operations, DevOps, and many other aspects of the cloud. With that, I wanted to thank you for your time today, and back to you, Stephen.
Thank you very much, Michael. So we're going to dive into questions from our viewers. First question is for Bharat. Bharat, how much does InfluxDB scale?
Hey, thanks, Stephen. We have it's huge. So basically, we have probably just the industry leading time series in terms of time series databases, the best scale that you can get.
All right.
So you're not going to have a problem with scaling if you use InfluxDB.
Gotcha. Thanks for clarifying. Okay, moving on to our next question. Corey, can we test a data migration prior to go live?
Yeah, in fact, you can test it multiple times. As you do replication, after that first replication is sent over, you can continuously test using just virtual databases. So once that replication is over, you can spin up a virtual database, test your applications against it, roll back, delete that virtual database, and keep trying it as you need to. So you can understand exactly how much time it's going to take, what any type of failures there might be as far as application connection strings, anything like that, or firewall rules, whatever you have there. It can be tested multiple times before cut live or before go live.
Got it. Thanks, Corey. Michael, our next question is for you. What is DevSecOps?
DevSecOps is a relatively new term. So as you go to the cloud, a lot of things intersect. So development, support and operations, observability, and security, they start to overlap. The biggest and the first place generally any organization start to implement DevSecOps is your build and deploy process. So customers will have their build and deploy scripts, and in that they will have hooks. So in some places it's called hooks, some places called web hooks, but it will, for example, do all the security and validation and code scanning and whatnot. And as if that pass the new code pass that all that security guidelines, then it start the deployment. If it doesn't pass the security guidelines, in that case it does not deploy. So that's a kind of good guardrail before the new release goes out. And there are many other areas where DevSecOps is kind of building security as a code to make the organization more secure.
I was going to ask, I've started to hear a term DataSecOps. Are you seeing that in your work as well, Michael?
Yes, I am. It's a lot around, PII, PCI data, HIPAA data, and the idea is as these data points are in data lake and in a distributed databases, how we make sure there's a security and governance in place, and that's where the data ops and data SecOps is around making sure that we have the right permissions for the right people, and the data is protected from people who are not authorized to see, and all that is now being done more and more using code in the data ops pipeline.
Understood. Yeah, we're definitely seeing ops culture kind of get around. Bharat, our next question is for you. How do you handle data protection and cybersecurity?
Well, all of our all the data that comes into InfluxDB, I mean, we use the standard protocols. So in terms of security, it's the standard. I mean, we have all the encryption protocols and everything like that. So, and we have our CISO does a lot of that work. I'm not as familiar with that, but if you guys have a specific question on security with InfluxDB, please feel free to send me a note and I'll forward it over to my CISO and get back to you.
Understood. And Bharat, what clouds do you run on?
All of them. So we have you can do Azure, AWS, or GCP.
Got it.
And
Okay,
you can run your own instance as well if you want.
Own instance, gotcha.
Yeah.
Okay, Corey, our next one is for you. Will continuous compliance mask across multiple databases so values are the same, such as names, addresses?
Yeah, most definitely. So we can set that up between different databases or really just data sources, right? So it could be some text file, CSV file that we have, databases, any type of data that we have that we need secured. We can mask any of that data and it will have the same consistent values between all the data sources.
Got it. Thanks, Corey. Okay, Michael, next question is for you. How easy or hard is it to move from IaaS to PaaS?
I think the answer is it depends. For the most part, what I see is easy. So if the customer is going, for example, SQL Server, Oracle on a VM or EC2, and they want to go to more platform as a service, it's very easy. We complete these kind of projects in less than a week, sometimes, or even faster. The cases where they may have external dependencies, they may need a operating system access, and third-party tools might be installed on the same database server. Things like that can make things complicated. Those are the places where we do assessment just to make sure that's the right database for platform as a service. But for the most part, it's very easy to migrate from a infrastructure as a service to a platform as a service.
Understood. Thanks, Michael. Okay, we're through our attendee questions, but I actually have some questions for you guys as well. First, and I'd love all of your input on this. If you really had to, there are folks in attendance today that are probably just starting their cloud journey, and many folks that are already on their way. If there's one thing, one lesson learned or kind of key challenge that you've been able to overcome with your work in the cloud thus far, what would that be? And Bharat, why don't we start with you?
Thanks, Stephen. Yeah, I mean, I think the greatest thing about the cloud is, it's consumption based, and you have the most, you can host something on premises, but you don't get the most recent code. Everybody, all the developer teams are publishing to cloud first, right? So I think there's just a greater kind of ability to do distributed systems in the cloud, and it's greater, you have just more kind of capabilities. I think that you can kind of use from various different, third-party folks or whatever, and it's just everything's kind of integrated better in the cloud. I look at cloud as like being more of that PaaS kind of thing where the system manages a lot of things for you. If you're gonna try InfluxDB, I say please try the cloud. Go straight to the cloud and free account, and that's a great place to start.
Understood. Corey, how about you? One kind of key lesson learned, something you were able to overcome with your work in the cloud as far as challenges or opportunities?
Yeah, really, I would say more from an opportunity standpoint is, not thinking in traditional sense of like, on-prem mentality and really switching that to the cloud. So instead of thinking, hey, I have to wait a day or two for a new box to be spun up, I can automate that, right? So I can have truly ephemeral environments if I need them for testing or development or anything like that. So that's one of the key issues, or I should say key things that I've always thought about when going to the cloud is, throw not everything away from the traditional data center, but really try to think more cloud native than traditional data center.
Got it. And Michael, last but not least, how about you?
I was thinking along the same lines as Corey. The going to the cloud, I think the one thing lesson learned, and I see I have so many projects I have completed with working with customers. The one thing I will say is be open to doing things new way. What I mean there is, as you go to the cloud, there are many options out there for databases and application security, observability. There are many options out there. Be open to learning new options and be open to changing and adopting new ways to do things which may be more efficient. So that's the one lesson learned. And it's kind of sometimes hard, when things are working and the technology or the tools, is sometimes hard, but you don't want the cloud to become another data center. You want cloud to be more efficient and helpful to you, and that means adopting things which are better in cloud.
Understood. Well, I would like to give a huge thank you for our speakers today for coming on board and sharing their insights and expertise. Once again, Bharat Bhatt, Director of Product Marketing at Influx Data, Corey Brune, Enterprise Technology Engineer at Delphix, and Michael Agarwal, Director and Global Practice Leader for Cloud Databases at Datavail. If you in our audience today would like to review this presentation or send it to a colleague, you can use the same URL that you used for today's live event. This will be archived, and you will receive an email once the archive is posted. And if you would like a PDF of the deck, you can go to the handouts section on the console once the archive is live. Also, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on June 30th. We'll let you know if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.